Hello, this is for the forensic science class, the colorimetry lab. You should already have it. This is on Beer's law and colorimetry. Okay, so this is the paper you should have. Okay, so it says determining the concentration of a drug using spectrophotometry and Beer's law. Okay, so it looks like that. I apologize for the lighting down here. This is my basement. I have all the lights on, but this is the only place I could run the lab. So we're going to go through this and collect data. The way we're going to do it is I have a set of known concentrations here. This is called a standard curve, or generate a standard curve. So I know the concentrations of each of these tubes, 1 through 6. Okay, so these have known concentrations of the drug of interest, and it's a colorimetric assay. So when the drug reacts with the substrate in there, it changes color to red. So the varying amounts of red, the more red that's in there, the higher the concentration of the drug. So we can see here, okay, that there's none in there. Okay, and this one has some. Let me turn the light around a little bit more. And this one has the most. Now, what I could do is I could just eyeball it, say, well, that's that amount, and here's the unknown sample. Okay, so, well, if I compare it to some of these, it's close, but I want to get a numerical value for this. Okay, I want to say how much drug is actually in there, and its concentration is in moles per liter. Okay, before we get there, though, let's see what equipment we're going to be using. So first of all, I have a colorimeter set here. Okay, the colorimeter, I can choose different wavelengths. Okay, green, red, and blue. Okay, so green, red, and blue here. And inside here, I have what's called a cuvette. Okay, the cuvette is a clear plastic rectangle, and I put the liquid in there, and the colorimeter shines a light through it. Okay, and the cuvette sits there, and by choosing the color of wavelength of light, I can determine the absorbance. That is how much it absorbs. So we're going to be using this table here. Okay, so I'll be writing in this data, and you can follow along. So I urge you to read one or more of the websites there, and the introduction to this, it describes how a spectrophotometer or colorimeter works. Now, if we go back here, the color that the drug turns the substrate, and the reaction is red. I don't want to use red as my wavelength, though. I want to use a complementary color, because this is letting all the red light through, but it absorbs other colors. In fact, the one that absorbs most is green. Okay, how about 565 nanometers? So green is the complementary color to red. So by looking at this, we can see how much redness there is. Okay, so it's actually not absorbing the red, it's absorbing the amount of green light. Okay, so if we look at this here, what we're going to do is I've already calibrated the spectrophotometer, or the colorimeter rather, to have for the wavelength we're using, and we're going to put down the absorbance. Okay, so on my computer over here, I'll show you. Okay, right now it's just a recording, but I have a program called Logger Pro set up there, and that's what's attached to the colorimeter. So that's going to give me the absorbance. That is how much of the green light is actually being absorbed. So let's start with this sample here. This is the clear one, and if I put that in there, Okay, so right now, if I look at the transmittance, okay, the transmittance is about 98.3 something, 0.4, okay, but I want absorbance for that. So I'm going to click on collect here, and we're going to get the absorbance value. Okay, so the absorbance there is 0.008. Okay, so if you see that there, 0.008, so we're going to record that in our data table. So it's not absorbing very much light at all. So 0.008 right in the absorbance. Now let's go to the next one. So for that, I'm going to take this first sample out. This has no drug sample in it. And I'm going to put it back in the tube. And we're going to collect the next sample. Oops. Okay, so now I'm going to collect the next sample here. And we know the concentration of this, and we're going to find out the absorbance. So I put it in the colorimeter. Okay, so I'm going to put it inside the colorimeter here. Same direction. And we're going to collect the absorbance again. Okay, so collect the absorbance. And that's 0.175. So let's write that down. Okay, let's do the next one. So I'm putting it inside the cuvette. So this is sample number 3. And they go up in concentration, so we should see an increase in the absorbance. Okay, so if we collect it again, that's 0.290. So let's write that in, 0.290. Okay, so I had 0.008, 0.175, and 0.290. Okay, take that sample out. And on to sample 4. Okay, so in the data table, you are given the concentration, so you can see that they're increasing. Okay, so put this one in and collect it again. So that's 0.401. Okay, so let's write that one in. So here's the data we have, 0.401. Okay, so we'll take that one out. It's a little tedious, but we need to do that so we can figure out, generate a standard curve of concentration, so we can find out the concentration of the unknown. Now we have to use the same drug and the same method here. Okay, so here's sample number 5. Put that in the colorimeter. And let's collect that. Okay, that's 0.498. So let's write in 0.498. And that'll take us to the last one. Okay, so this has the highest concentration. It's 0.20 moles per liter. So that's the concentration of the drug in there. Put it in the colorimeter. And then collect that. Okay, so that's 0.584. So that's our standard curve. Okay, so write this in your data table. 0.008, 0.175, 0.290, 0.401, 0.498, and 0.584. Now, we are going to find the absorbance of the unknown sample. Okay, so we take out sample number 6 here. And we put in the unknown. Now, we need to have the unknown somewhere between 0 absorbance and the highest absorbance here. Okay, so it's going to be somewhere within the middle, but we're going to see exactly what it is. Okay, so here's our unknown sample. Put it in the colorimeter. Collect the data. Okay, so that's 0.277 for absorbance. So let's write that in. So our unknown is 0.277. So you see that that's somewhere within the range of 0 to 0.584. So 0.277. So make sure you have the data there. Fill out the data chart. Then what you are going to do, okay, let me get back into so I can see the recording.